very good morning to you, and it's 1:45, and here we are, just doing another little quick review, this time a piece of test equipment. And I know everybody else on YouTube has done multimeter reviews, and everybody says, oh, not another review, not another multimeter. Well, yes, we've all seen the Aneng 8008 or whatever they are, and yes, you can get them for £10 and they're fantastic meters and all the rest of it. But what struck me about this one, and I thought, you know, do I really want to go for another multimeter? And then I thought to myself, yes, I do need another one because I haven't ever got enough, have I? It's different in such a way from the Anengs and all the other ones that I've seen, in the fact that this is auto-ranging, which I would say is quite unusual considering the price of it. Now what I'll do is let me just get you the review, not the review. Let me just put my finger on the button and see if I can focus on my screen. Right, so there you go. You can see £10 and 23 pence. This is the Mustool MT66 True RMS 5999 counts. Digital AC, DC, current, voltage, frequency. If I click on that, let me click on that. There we get the full advert for the new one, and it's already gone up in price. So these days, yeah, £15 is the current going rate. It's, where were we? Voltage, frequency, resistance, capacitance, temperature, tester, duty cycle, diode, continuity, voltage, AC alert. Basically, it seems to do everything. There's already a video of somebody testing something with it, but let's give it a go and see just how good it is. So the first thing I'll do is focus you back on the bench. So there we go. Now I've put something under the back end because I'm trying to avoid the lights above the bench, which are shining directly on the screen, and it's just a case of so that you can see what's going on down here. Now it turned on, we had a beep, and it's sitting there quite happily. Now I'm going to roll my power supply leads out here, which are all tangled up, and I don't know if it's going to be an unfair test, but I'm going to sit it next to my Fluke 77. Now we're on volts DC because that's what we're on at the moment. Now these are both auto-ranging meters, as you can see, although this 77 doesn't have all these extra functions on it. But again, this is getting on for 20-25 years old, so I wouldn't expect it to. The probes on the Mustool actually have a cover, so you've just got a small point, or if you pull it off, you've got a great big pointer. So I'm going to connect the positive there, and I'm also going to connect the positive of that meter to there, so they're both going to the same. I'll do the same on the negative terminal. It's quite unusual that when you pull that off, that then turns red and says 1000 volts category 3. Surely you'd want to expose less of the terminals to stay within category 3, but hey ho, what do I know? I only play with electronics. So there we go. What we've got is straight through. They're both connected together. The power supply is not switched on at this point. I don't know what the voltage on the power supply is set to because it's turned off. I can't actually preset it on the particular power supply that we're connected to. So they're both reading 0, and let's fire the power supply up and see what they both go to. 11.54 on both meters. So for that, that's not bad on an auto-ranging meter. Now I'm going to lean across, and you'll just see my arm in the corner of the screen here. And I'm going to track it up and choose a random point. Okay, now we've got a slight difference between the two. 23.73, 23.74 on the Fluke, 23.75. For most uses, it's climbing up. The power supply is doing what it wants to do. For most home uses and for most electronics uses, you're not going to be worried about 1/100th of a volt. 10th of a volt, 100th of a volt. Will you really be worried about 100th of a volt? Unless you're doing some sensitive voltage measurements that require a chip to differentiate between 1.2 and 1.25 volts. It's going to be good enough. Now let's drop it down to the lower end. And right now on the Fluke, it's just gone into the lower of its auto ranges. And 1.509, 1.512. The Fluke is actually not very stable there. This is actually, I don't know, they're both not very stable looking at them, but they're both reading, again, within the 0.2 of a volt. So not so bad. Let's drop the power supply down to minimum, and it really hates going this low. 8.2, 0.82, 0.82, and as you see, it's now got down to thousandths of a volt. It's accurate enough at that range. You really don't need vast accuracies. What are we talking? 1/1000th of a volt difference there. So I'm going to bring the power supply back up. Just choose a random. That says 13.7, 13.82, 13.82. With 13.81, they're both stable down. Power supply says 13.7. So, I'm not going to complain about that. So that's the auto ranging on DC side of things. Let's see what it's like on AC. So let's get these two lines, and just because we're crazy, put it into AC mode and shove it in the mains. And there we go, 240.7, and the meter itself is showing 240.6. So they're both agreeing now. Now on this, I can actually click the button. It tells me that we're on 50 hertz here, and if I do that, it also says we're on 50 hertz. So not only is it telling me the voltage, it's telling me the frequency of the mains as well, which is actually a function that this Fluke can't do. So that's AC mains. Let's just unhook it from there. Now we saw what that one's reading. Do I need to shove these probes in there just to show that we can read AC mains with the Fluke? Or do I have to take the crop clips off? There we go, 239, 240. What's that say? That's still on. Let's go to volts. 241.9. 240.32. So, it's, if you're playing with AC mains, 1 volt isn't going to make a great deal of difference. You're going to get a shock if you stick your fingers in it. So don't do what I did just there, folks. It's not going to be good for your health. Your other standard tests, you've got a millivolts AC DC range. so you can check low voltages. Here you've got a standard continuity test. You can also select diode check, so you can measure your forward voltages of your diodes. What are we on here at the moment? This is capacitance. Now, do I have a small capacitor to hand? 9.1 nanofarads. So, let's have a look. 1 0 3 zeros, 10,000 picofarads. Yeah, that sounds about right. 10 nanofarad. And of course my fingers will be affecting it. So yeah, capacitance. It works great as a little capacitance meter. AC alert. Got no idea without reading the manual, I'll be honest. EF. Is it going to warn me that there's AC around? I don't know. I'm not going to stick the probes in the mains just to check. It does come with a thermocouple, so you can read temperature. Frequency again. I don't know. Let's. £50, yeah, so it's reading frequency there again. Microamps, milliamps, and amps. It says 10 amps. So again, same as the Fluke. So, how do I rate it? Well, it's a cheap Chinese meter. It's not going to be built the same as the Fluke. It's nice and simple and straightforward, easy to use, especially for the beginner. As long as they know what these functions are, what this symbol V with the steady line and the dots mean to say DC. But then Fluke doesn't give you any clues. But then realistically, if you're buying Fluke meters, you generally know enough about electronics to want to know why you're going to need a Fluke meter, and you're going to know what all the symbols mean. Voltage with a wavy line, AC, as I say, AC DC on the millivolts setting, all your functions on the resistance range. As I say, I'm going to have to read the manual and find out what that alert is. One function I haven't mentioned, which apart from the hold function allows you to hold your maximums, is if you push it down long enough, it backlights. So if you're working in the dark because your power's gone down and you're trying to find the live wire, then yeah, you can backlight, push it, hold it down, and you can backlight your thing. Now, one thing I will try, because these probes look fairly similar, I'm going to take this crocodile clip off my Fluke. I'm just going to see. Yeah, so they're not supplied standard, but they will take a banana clip connector. That makes it a lot more flexible, because if you say wanted to connect that to a chassis, you'd clip it to the chassis, and there you go. You can have just the one probe, so when you're sticking it in high voltage circuits like guitar amplifiers or vintage radios or whatever you're doing, you don't actually have to hold both probes constantly. So that's the fact that these tips without the extra plastic on will allow you to do that, is a great idea. Also, if you are working in tight spaces, the ability to have this shroud again is a very good idea. And in one way, it actually makes these Fluke leads a little bit sort of lacking in features. The only thing I'll say about the leads on these is they don't feel as flexible as the Fluke leads, and I can guarantee that these will be rated to 1,500 volts, whereas 1000 volts into these. You know, it says Cat 3 600 volts there, Cat 2 for 1000 volts. Would I want to try and measure 1000 volts through them? Probably, but that would be pushing it. And as for the internal cable without snapping it, I've got no idea. So with that, all I can say is, if you want one, go to Banggood and buy yourself a £15 meter.